Hi everybody, this is Dr. T. Anthony Santosh, Assistant Professor of Chemistry, St.Joseph College of Arts and Science, Cuddalore. Now in this video, I would like to discuss with you few typical phase diagrams. What is actually the phase diagram? Phase diagram is a graph or map which explains the equilibrium between different phases of a substance or different phases which are in equilibrium with each other and other details for a particular variables like pressure, temperature, composition or concentration. When we are having a phase diagram, that phase diagram explains several equilibriums which are considered for that particular variable like pressure, temperature and other things. Now in this diagram of I would like to explain you two typical phase diagram which are having typical behavior. First I would like to explain you the phase diagram of helium. Helium, as far as we know, it is a gas, and helium can be liquefied according to Joule-Thomson effect, and helium can be solidified with special conditions like Linde's refrigerator and other things. And in the case of helium's phase diagram, as we are looking in the picture of graph, the variables or properties which are picturized here are temperature versus pressure. In this case of phase diagram, helium has four different phases. You can see what are the four different phases: helium solid, helium liquid 1, helium liquid 2, which is called superfluid, and helium gas. What is the speciality of this diagram? It is the only phase diagram which consists of two liquids. And now let us see the important points which are picturized in the phase diagram. Helium behaves unusually at low temperatures. For example, the solid and gas phases of helium are never in equilibrium according to the picture. Even the temperature is very low, we cannot keep the helium gases. They are so light, so they vibrate with large amplitude motion even at very low temperature, and the solid simply shakes itself apart. Solid helium can be obtained but only by holding the atoms together by applying heavy pressure. A second unique feature of helium is that pure helium has two liquid phases, and the in-between curve of dB is called lambda line. The phase marked helium 1 is normal liquid. Thus helium 2 is a superfluid. It is so called because it flows without viscosity. Helium is the only known substance with a liquid-liquid boundary in its phase diagram. And we can see the critical point and other things in the phase diagram. Now let us see the phase diagram of carbon dioxide. This carbon dioxide phase diagram is also a typical phase diagram because it also shows a different behavior. You can see in the picture A, B, C, D like points in the phase diagram of carbon dioxide. The point A triple point has a pressure value of 5.11 bar and 217 Kelvin, and the point C, which is known as the critical point, has the value of 72.8 bar and 304 Kelvin. And we can see three different phases of normal carbon dioxide here with another one supercritical fluid in the phase diagram. So this picture of carbon dioxide can be noticed include the slope of solid liquid boundary. This positive slope is typical of almost all substances. The slope indicates that the melting temperature of solid carbon dioxide rises as the pressure is increased. As the triple point, that is 217 Kelvin, 5.11 bar, which is symbolized in the graph as A, lies well above the ordinary atmospheric pressure. So liquid carbon dioxide does not exist at a normal atmospheric pressure. Whatever may be the pressure or whatever may be the temperature, the solid sublimes when left in the open atmosphere. So it is called dry ice. The solid carbon dioxide immediately sublimes from solid state to gaseous state. So it is called dry ice. To obtain liquid carbon dioxide, it is necessary to create a pressure value of at least 5.11 bar. So if the pressure is lower than that, then we cannot have a liquid carbon dioxide. Cylinders of carbon dioxide generally contain the liquid or compressed gas. If both gas and liquid are present inside the cylinder, then at 20 degrees Celsius the pressure must be about 65 atm. When the gas squares, so we have this kind of typical behavior in the carbon dioxide phase diagram. Thank you.